Hello everyone. Now we are going to see about this source follower. In the previous video we have discussed about common gate stage. So in this video we are going to see about source follower. So first of all, what is source follower? Source follower is nothing but common drain. So common drain stage means what? Drain is common to both input and output. Here we are giving the input at gate side, we are taking the output at source side. This is what common drain stage. Here also in the source follower also we are going to see what is the gain and what is input resistance, output resistance and biasing of the source follower. Here in this common drain stage, if my input is increased by a small amount, let us take del V in a small amount, what will happen? The voltage between gate and source, that is VGS, also will be increased. Because of this, at this source the current at this source also will be increased. Because of this, the output voltage also will be increased. This is what happening when you are increasing the input voltage by a small amount. Next we are going to see what is our input what is the gain of this source follower. So for finding that gain, we are converting this diagram into small signal equivalent diagram, small signal equivalent of source follower. Here we are giving the input at gate, we are taking the output at source, drain is connected with ground, and here we are also considering channel length modulation. So R0 is also included. This is what the equivalent circuit. Here in this equivalent circuit we are taking only resistance. So we are having the input voltage and input resistance 1 by Gm, and then output resistance R0, RL, both are parallel. So we are writing we are writing that in a single resistance RL, parallel R0 and Vout. Now we are going to calculate what is the gain. So to find gain we need output voltage and input voltage. So what is our output voltage? So V out equal to what? V equal to I into R. So what is the I here? I is nothing but this current source. So GMV1. I is GMV1. And what is our resistance? The resistance is parallel of these two resistance. So R0 parallel RL. This is what our resistance. So multiplication of these two will gives us output voltage. So on what about V in equal to V1 plus Vout, V1 plus Vout, that is whatever V. So we are having Vout, that is GM V1 into R0 parallel RL, and V in equal to V1 plus Vout. Now to find gain, we have to we are taking this equation 1 and 2, 1 divided by 2, Vout by Vin, that is whatever gain. So if we are finding Vout by Vin, we will get this value divided by this value. Here also we are having Vout, so we can substitute this one equation here. So your equation will become like this. Here we are having V1 common, so we take the V1 outside and both V1 will be cancelled. Finally you are having this value. Here also I am taking GM outside, so both GM will be cancelled. Finally I am having R0 parallel RL divided by 1 by GM plus R0 RL. This is whatever gain of source follower. This value is less than unity. And next we are going to see what is the input resistance and output resistance. So here when you are input resistance, in the sense we are giving the input at gate. So here if we are having resistance, what will happen? That input resistance won't affect your circuit behavior. So this circuit will be acts like a previous normal circuit only, that won't affect your circuit behavior. Then what about output resistance? So for finding this output resistance, we are constructing small signal diagram. Here the input voltage at the gate is grounded and we are having the load resistance, and here channel length modulation is not neglected, so we have to consider R0. And here this is both are equal only, but here we are considering the input resistance 1 by Gm. So 1 by G input resistance R0, both are parallel, and for finding the output resistance we have to consider all these resistance now. So 1 by Gm is parallel with R0, these two also parallel with RL. So all these resistance are parallel to each other. So your R out will become like this, 1 by Gm parallel R naught parallel RL. This is approximately equal to 1 by Gm parallel RL. So this source follower is having high input impedance and low output impedance. So what about this biasing, source follower biasing? This is whatever circuit. Here we are connecting gate to supply voltage VDD through this RG. So gate and drain both are connected to same voltage VDD. Because of this voltage, your M1 will be in saturation region, because both the voltage are, both gate and drain voltages are same. So your transistor will be in saturation region, and we are having coupling capacitor, and at the source we are having a resistance RS. Here your input impedance will be reduced from infinity to RG. And next we are going to find the bias current. So bias current ID. For finding this ID, first we are going to find what is our VDD value here. So VDD through this path, VDD equal to the voltage between these 2 points VGS plus the voltage across this resistance, that is V equal to I into R, so ID into RS. So VDD equal to VGS plus ID into RS. This is whatever VDD. So next, here we are neglecting channel length modulation, and we are writing our drain current that is equal to for saturation region, drain current is this one of mu n C x W by L VGS minus VTH the whole square. Here we are having what is VGS. So here VDD we are having, from this we can write what is VGS. VGS equal to VDD minus ID RS. Substitute this value here, VGS, in this place substitute that value. So your equation will be like this. So here your bias current depends on the supply voltage. So if your bias current is depending on the supply voltage, this will lead to so many problems. How to avoid those problems, how to overcome that failure is, that is by using current source. So instead of this resistance, we can replace that by using one current source. So if you are doing like this, the dependency of this supply voltage, the problems will be reduced. And this is what equivalent circuit. Here instead of current source, we can also utilize one NMOS transistor with by constant biasing voltage. So this is what about source follower. Thank you.